Well, hello and welcome everybody. As Dan said, I'm Neil Giratana, at Neil's Mind for Twitter. We used to have to give a lot more information to people about how to contact us, like email and all this stuff, right? Essentially, I am a senior software engineer for Xperi. I've worked on a number of tech startups and founded a couple myself. I'm incredibly passionate for AWS, and AWS Serverless has definitely been a passion of mine for about a year and a half now. Truly invested in it. And so I lead a team of developers that are spread all over that are building an application for Xperi. If you don't know what Xperi is, if you've heard of HD Radio, that's the product group that I work within. We have HD Radio. We work with radio stations all over the world. So essentially, my team is building a portal to work with all of the radio stations on the planet so that they can update their information on your radio when you drive down the street. And so with serverless, it's all about that portal for the radio stations themselves. Now, in terms of this AWS serverless thing, I was thinking back, and I mentioned this to Robert, like we just talked about serverless like less than a year ago, and Robert did a great presentation. I was actually going back through his slides today, but a couple of things have changed that I think are pretty exciting. First and foremost, and this happened in April, if you're familiar with AWS SAM, so SAM is the serverless application model. AWS SAM, they came out and they open sourced the entire model, meaning what SAM does is it takes, you give it a template file to say this is what I want to build as a stack, a CloudFormation stack on AWS. And SAM sort of simplifies that for serverless. And then it converts it into the CloudFormation templates so that it can deploy online. The key about them open sourcing the back end of it is that now, and this is the new thing, I went too far, is the SAM CLI, which I'll talk about, was completely refreshed 9 days ago. So if you've ever heard of SAM Local no longer exists. It's now SAM CLI. It's all merged together, and we're going to talk a little bit about that tonight. So it's sort of some exciting times. So we're going to talk tonight. If you're not familiar with serverless, or you've never seen a presentation before, I'm going to try to give you sort of an idea, an overview of what it is. I'm going to try to do that briefly, and then move on. And most of my presentation is more about tooling and how you leverage serverless in a way that's approachable. And so what we're going to do is have a little sample app. It's completely contrived. This app doesn't exist. It's just a way to demonstrate, right? So work with me here. Providing the latest score for every game on the planet, hockey, football, soccer, whatever it may be. Imagine a web-based app where you can get every score on the planet and you can submit it. So your little 10-year-old is having a soccer game here in Columbia. You could post that score on the weekend or otherwise, and other people could see what that is. That's the concept. For me, it would be great to know the CAP score starting at 8. So the features of this system, we're going to keep it simple. As a score submitter, I want to be able to create a game, and I want to be able to update a game. Those are the two things that I want to complete. As a sports fan, I want to view the latest scores, subscribe for updates, and actually get notified on my mobile phone when a score is updated. Now, we don't have all night, so I can't take you through the entire system to build this whole thing out, but it's a means of talking about it. The other requirements here are I need to be able to start this app, I'm going to build it, and I need it to be able to scale to have 5 games posted every day. But eventually I want to get it to a point that there are 10,000 games posted every day, and maybe at some point 1 million games a day. And someday, and maybe tomorrow or maybe next year, and I have to have a way of controlling costs in such a way that I can make this system work, right? I can't build it full scale for 1 million games or 10,000 games today. I need to build it at a level that I can afford so I can get this thing off the ground. And then finally, it must be available or fast to all points of the globe. So it's not just something for here in the DC area, but it's on a global scale. And what that means is, obviously, the internet is not mostly not restricted in terms of how you access it. But if you talk to folks that are in other parts of the world, they would tell you when they hit websites here, they can be slow, and when we hit websites elsewhere, they can be slow. The idea being, how could we distribute it? And so in a typical application like this, what you would expect, at least today, is I'm going to have a single page app in the front, and I'm going to have an API in the back end. And what I'm going to describe tonight is the back-end side, right? The API and how we would set that up. And so in a traditional architecture, if you think about that back-end, the first thing I would do, and I was a Rails developer before I started getting more into serverless, I'd fire up a Rails console, Ruby and Rails. I'd set up my application, and I'd have a dirty word monolithic app to build this thing out. And it was easy. I could get going. But what I come to realize once I go developing for a while is, well, I need a firewall. And then once I put the firewall in place, well, now I need to consider what I'm going to do for when I scale. So now I go from 5 to 10,000, and all of a sudden my application server might not be operating as it should. And clearly, I could use a service like Heroku, which I would typically do in Rails, or some other sort of hosted service, but I'm still considering on a server basis. So if you're familiar with Heroku, I can set up and say, okay, I want to launch a Heroku app, and I determine how many sort of instances I want to use, what the resources are. And I'm always deciding that. Well, what happens if our score.io gets picked up by Sports Illustrated? But I didn't know, and it dropped. And all of a sudden, I've got 5,000 games come in, and I'm sleeping in on Saturday morning, and my servers are on fire, right? I'm trying to deal with that. In larger scales with organizations, anticipating that scale can be hard, and it requires people. So in that case, I probably want to load balance this thing, and now I'm dealing with 2 servers, or 2 server stacks, or 2 instances, and I'm dealing with a database server, and I'm dealing with firewall. And so after that, once I do get to 10,000 games, now I'm dealing with scores of horizontally scaled systems across, right? And ultimately, it just makes me sad, because all I really want to do is build software. Like, that's what I love. The other thing that I haven't dealt with in any of these diagrams so far is I have to write my own authentication, right? So I'm dealing with the authentication service to it and integrating that with my API and with the firewall part of it. I also haven't talked at all about that one requirement I mentioned earlier, which is I want people to be notified on their phone. And clearly there are services to do that. I mean, Twilio's been around forever. There's other ways to do notifications and SMS within, but I don't want to think that much about it. And so in a perfect world, I'd have a way to queue this stuff out and have it sent outward. And so from there, if instead, well, actually the final things that I have to think about are, I have a lot of other headaches to deal with, right? If I'm dealing with servers, I'm dealing with things like, do I have backups, right? Not that I can completely abandon that with serverless. Are my servers secure? What's the Apache config? And if you've ever done web application development and launched your own stuff, like, it can be really intensive. And I love to build software, right? I was a network manager. I left that, so I didn't have to do that stuff anymore. So there's a lot of headaches that go with this. And so ultimately, I just want to build software. On the other side of the serverless side, you have a number of component pieces. So in serverless, we have Lambda. And if you've ever heard the word serverless, everybody says, oh, serverless, that's Lambda, right? Well, serverless is about a little bit more than that. And in this case, serverless is really just a service that's up on the internet that I can upload code. And then certain events happen to trigger that code. And those events could be that it's scheduled, like a cron job. It could be every time a file gets uploaded to a server, run this little routine. And in the past, when we talked about Lambda, that's all everybody thought about. They thought, if I upload a video and I want it transcoded, then I can write a routine and then it's going to spit it out on the other end. And that's kind of cool, but I don't think it takes the full sort of scale of what you can do with Lambda and with serverless. And there's a lot of different events you could do. I could process emails that come in. But I can also, as this on the left is, I can use API Gateway that allows me to essentially create a RESTful API and put Lambdas behind it to create a full-sized API system. And I'm going to show you how to do that in just a moment. So API Gateway is the equivalent of that firewall I showed earlier. It's also the equivalent of the load balancer I showed earlier in terms of distributing load out to different places. Okay, so API Gateway is the front end of your RESTful API. Lambda is what does the processing of things. And then when I showed that database server in the back, that was Postgres or MySQL or Oracle or take your pick of relational databases. In Amazon, they have DynamoDB. Now, I will tell you, DynamoDB is quite amazing and at times really painful. DynamoDB is a document database. It's not a relational database, and so it has all of the challenges and maybe a few more that document databases have. But it scales like crazy, right? Almost without thinking about it. And the second thing it does is, unlike a relational database or a typical relational database, it has what they call DynamoDB streams. So imagine if every time I save a record to the database table, imagine if that, without me doing anything, was loaded into a stream, right, that other Lambdas could listen to, right? And I'll show you an example of that in a minute. But basically, it makes it so that I can have data flow around my application in ways I couldn't necessarily do relationally with a queuing mechanism. The other thing in our application we're going to talk about is SNS, which is Simple Notification Service. All that is that's what takes care of our mobile notifications. And we'll talk about that in just a bit. And so if I combine all of those together and I say, how do I create this overarching serverless application that I want to build, right? How do I create that? What are the component pieces? These are essentially the component pieces. I have an API gateway that I'm going to spec out. I have 5 Lambdas, one for each function, right? Add score, update score, view score, subscribe that allows a user to subscribe for notifications, and then send notification. And what you'll see here is all of these are just RESTful calls. The one down here on the far side, the send notification, well, that's that DynamoDB stream thing I mentioned. So imagine if I post a score, add score puts it in the database, and then add score is done. It doesn't think about anything else, right? But automatically, DynamoDB puts that into a stream that this Lambda is listening to. It waits for that event, okay? And it runs and it'll send that notification. Now, the very cool thing about it is, well, what happens if this isn't running at the time? Or the code has a problem? Or some other issue? Do I still want those notifications to go? Well, in the case of DynamoDB streams, it has guaranteed delivery. And it'll actually stop, and it puts them in sequence, at least for 24 hours. In sequence, it will guarantee the ordering of that delivery too, which sort of matters for scores. But I can tell you in a system that we've built, one of the things that we do is we combine different tables together. And we do what we call rematerializing. So we rematerialize a radio station and combine all the broadcasts together when something changes. We really, really, really need it to happen in order so that we can trust the data coming off of the stream. And so it takes care of that. So it's a pretty nice way to go. The nicer thing is, and I will say, so here's the first lesson learned. That was one of the pieces to this. The first lesson learned for us for serverless was, it's really hard to get your arms around the entire system. Like I have these Lambdas, and I have this API gateway, and I have DynamoDB, and I have all this stuff. And one of the things that was really a challenge early on was, how do I get my arms around the overall system? And so one of the ways that you get your arms around the entire system is, we write the code for all of the Lambdas, but the entire specification of the system is put into what they call a SAM template, or a CloudFormation template, okay? It's just a text file, and I'll show you what that is in just a moment. Any questions so far? Okay. The other thing that it can take care of for me that we're not going to go into tonight is, I mentioned, I haven't talked about authentication. It directly can integrate both in the front end and on the API gateway, Cognito, which Cognito is an authentication service from Amazon. I would tell you when we first started our application, we actually didn't use Cognito, we used Auth0. Anybody ever used Auth0 before? Our experience was mixed. And the reason it was mixed for us, I mean, it was pretty good service and it helped us accelerate our initial development pretty quickly. The issue that we had was two things. It seemed like they had scalability problems, so they had some outages for their back-end API, which caused us problems because we are trying to create users using their API. And then when they had those problems, it didn't directly affect us, but it made us kind of nervous. They said, oh, you know what? The way that we set up the data structure in here is not really scalable. So now we're not going to let any of the free customers access that anymore. Like they completely changed what the API access was, and we weren't free, but so it didn't affect us. But it made me sort of anxious as to, well, if they can just like within 2 weeks just sort of swap the API, I don't want to deal with that in a year. Like if you decided you made a design decision problem, like that's I can't handle that. So we actually transitioned our application recently to Cognito, and we've been pretty happy with it so far. It's somewhat limited in certain ways, but it's pretty good.
It's expensive too.
Yeah, I'm trying to think, and I've got the cost for this stuff, but it's, yeah. So anyway, and then the other thing that this does for me that I had not addressed yet in the traditional approach was this notification of the phone down below, right? The SNS system just takes care of phone notifications. I don't have to figure out, I don't have to worry about third-party services, and I can use a lot of the native queuing that I can do within Amazon. And so if I go back to all the things that I was really concerned about early on, most of those things sort of go away. The backup part of it, there are ways. DynamoDB, there is a backup service, right? But here's the thing. With DynamoDB, if I'm thinking about my data backup, DynamoDB, as soon as I deploy that table, without me doing anything, it automatically goes to 3 different availability zones. So 3 different data centers, and I got it for free, right? When I deploy my Lambdas, when I talk about my data center going down or my servers being secure, when I push my Lambda code up, it automatically deploys to multiple availability zones. So if any one data center were to go down, I'm still running, right? And I did nothing to do it. It's just by default, okay? The 2 that I left on here, the how do I replicate when I need a second database? DynamoDB does spread it amongst different availability zones. So in Amazon world, and I'm not going to begin to draw a map of the world, but let's just say that Europe and Asia and stuff are over here and we're sort of over here. When you have an availability zone, if you've ever been to Ashburn, Virginia, there's just data centers as far as you can see, right? Well, so if I was pointing at Ashburn, there might be 3 data centers that are spread geographically by a number of miles. It's not just in Ashburn, but a number of miles. An availability zone would be US East 1, which is Ashburn, right? US East 1, they have multiple data centers, so they spread it across. But what if I wanted EU East 1, or West 1? This is a different region, so these are regions, and then inside their availability zones are essentially data centers. In order for me to get it to go in multiple places, that takes a little more work. So I could spread my database and put it in multiple areas across the world, and there are very definitely straightforward ways to do that. So I can't replicate automatically to other places, but it does replicate within the availability zones in a pretty straightforward way. The other thing is how much CPU and data storage memory do I need per function instead of per server? That's one of the very few things that I do actually manage is, and I'll show you this again, is I can control, so when I showed you that the grid with the different lambdas, on a per function basis, I can assign how much memory each one gets. So a lot of my problems go away. Let's dig in. So here's the second sort of lesson learned for us, and this has changed very, very recently. This is based on those 2 things I showed at the beginning. With AWS Lambda, ideally, and I'm going to switch here, I want to be able to develop locally. So as a developer, right, I care very much about my environment being able to get started working quickly. I believe that every application that a developer should be able to hit something like start and be able to run their app, right? Some things are more robust and scaled than that, but for the most part, most applications, and clearly the application I'm showing, score.io, I should be able to run that locally, okay? I should be able to run the front end and the back end. I should be able to run Lambdas just exactly like I run them on AWS, but I should be able to do it on my local machine without having to deploy anything. And that's what it used to be called SAM Local, but is now SAM CLI allows me to do. So I can locally, on this machine, build, test, and debug my serverless apps. I can launch a full-on API server locally with a single command. I can invoke Lambdas from the CLI. So if I want to pretend like I'm going to do a notification to those phones, I can invoke that event that came out of the DynamoDB stream. And I can generate payloads, which are kind of hairy beasts. It's a little bit more esoteric. I'll leave that one out for a sec. I also can initialize ready-to-deploy SAM applications in a single command. I can basically do the equivalent of yarn deploy or something deploy and have it actually take and launch this entire app up onto AWS in a particular place. And I'm going to run a little bit without a tightrope here. We're going to try to do this.
So couldn't you do the same thing by actually using like Cloud9 and running actually in AWS?
You can. Cloud9's interesting. So I mentioned to a few people earlier, like I'm a code editing fanatic, right? I switch editor, and he would tell you because we worked together a long time. I switch like every 3 months. I tried Cloud9, particularly when they announced it at reInvent. That day I had an account going and I was trying to log in and do all that stuff. It's good. It's a little clunky. One of the places where it was clunky for me, and I think it's part of, Cloud9's been around for a long time, and Amazon bought them more recently. The integration of the authentication was a little weird. We, not to get too deep in the weeds, but basically we give every developer gets their own AWS account under an organization account, right? So when I log into the organization and then I access my particular user account when I'm building in Cloud9. About every 90 minutes, it would pop up and say I had to authenticate. And all I had to do was click a button and it would keep going. But I'm coding, man. Like, I don't want that. So it was a little bit clunky. So it's not exactly the same. The other thing is that some of the other services that you might emulate aren't quite the same either. Yeah, it was good. It was the best that existed back then, but I think we can do better now.
So what are you using now? Not to go off on a tangent. What's this month?
A code editor?
Yeah.
VS Code.
Okay, yeah.
Yeah, and I've been using that. I would say that's been the longest that I've used. I used Sublime. I've used Atom extensively. I don't know if you've never used VS Code, but you have used Atom. Imagine Atom but fast, and with a deeper ecosystem of plugins.
Yeah.
And I don't know. My assertion would be a little bit better cared for. Like they come out with new updates every month that are spot on for what I'm looking for.
Okay. So just curious.
So this command here, SAM init, and this means runtime. So I'm going to say, hey, I want to start a serverless application, and I want it to run node 810. Okay. One note for everyone out there, if you're thinking about using serverless with Node or with JavaScript. So they tend to run a little bit behind on Lambda. About every January, everybody freaks out that they're having old. So this past January was Node 6, and everybody was in a panic because they were coming out with, what is it, Node 10 now? And we're so far behind, and my company would come to it if only you would upgrade. The experience over the last 3 years has been every April they come out with the next one. So if you're looking for that, this year it was Node 8, and it came out in April just again. So what I'm going to do is I'm going to actually start a serverless app with exactly that command. Let's give it a go. And we'll do the no-no that we never ever do, which is build code on the fly. All right. So I'm going to do SAM init. I may or may not have done this earlier. So SAM init runtime, so I spelled it out, Node.js 8.10, and this is just N for name. I'm just going to name the directory I'm going to put it in. And so what that did is, if I look at the directory for AWS Columbia, it gave me a new app, okay, that's built in. So we're going to look at that app. Hopefully you guys will be able to see this well enough. This is VS Code. Okay, so up here is the directory of the files that I just created. Now, So essentially I get a folder with a hello world Lambda. I get a get ignore, a readme, and a template YAML. Okay, so you remember I talked earlier, I have a template YAML that defines my service. And what this is going to end up doing is it's simply going to return a web page, and I'll show you why. I'm going to go to my API server /hello, and it's going to say hello, and it's going to tell me my IP address is what it's going to actually show here. If I look within the code here, and they're nice enough, and this is part of that new CLI. So what's nice is they actually include tests, which I love, right? And I will tell you that's another lesson. It wasn't a lesson learned. We knew it. We didn't know how important it was going to be. But test-driven development really saves your butt with Lambdas because those unit tests have to be really strong. So I love that they included it here. So within here, if I go and I'm going to look at the code for this app, first we'll take a look at the template. Just slightly. So this is just a YAML file, and all it does is this little header information that defines that this is a serverless app. It's got a little description, and I actually would prefer that they made this a little bit smaller. You could have just done that. And then as we scroll down here, this is the hello world function. And this is it in its entirety. This little bit will actually take and launch a serverless application up on Amazon. So it's my hello world function. It's a type of serverless function, which basically means it's a Lambda. I tell it where the code is, so this is which subdirectory, what the handler, so this is the file. And you can look at this documentation. I'm not going to take every bit of serverless, but this is just pointing to what function are we going to run in that directory, what the runtime is. I can set environment variables, and then this defines an entire API gateway, right? That's cool. Like, the fact is all it's saying is within this hello world function, it's going to use the path /hello on a method of get. That could be post or patch or anything like that. And so with just this little bit of code, this is defining an entire serverless app. It's not my entire app that I had before, but what it is, it's going to define that API gateway that I showed, and I'm not going to do that little character, with a Lambda, right? And then it doesn't actually go to a database in this case, but you can imagine that being shown in. And I'll show you an example of one of those files later. But the cool thing is it's going to give me a gateway, it's going to give me that Lambda. And all I need to do to get this guy running is I've got to do two things. I've got to go into here, and this looks just like any other Node.js type app. I need to go into this directory. I'm going to drive him crazy with the camera. I'm going to go into the directory of this app, and I'm going to go into that hello world function. That's what has the Node Lambda stuff. And I'm just going to type yarn install, the same way I would with any Node application. And that's just going to download and install any of the Node modules. So if I look at the directory again, I have one more folder, which is Node modules. And that's working off of this simple package JSON, which if you're familiar with Node, you'd recognize a package JSON, right? So I ran yarn install. Now the only thing else I have to do, go back to my root directory, and I'm simply going to type SAM local start API. Switch over to a web browser. I already tested this once. I'm going to refresh this, and that's running my RESTful API gateway locally, right? So it was that simple to get it started, and it hot reloads, so I can take and change things. So for example, in here, if I go to my file that actually runs that, this is the entirety of the Lambda. If I go in here where it says hello world, hello Columbia, refresh, and it's going to hot reload it within that API gateway. So this is a really simple example, but the bottom line being is in about 3 lines of code, I downloaded and installed, or essentially generated, a serverless app. I now have the ability to run Lambdas, and I have an API gateway in front of it. Okay. Any questions so
Small
far?
question, because the fact that
Please.
you're running locally right now.
Yep.
You're not running on AWS. In
Correct.
order for you to have the gateway, as you're talking about, that must be running locally if you're really running that gateway inside your own app, right?
In order to run the gate. Yeah, so that's running on my local machine.
Okay, so you have a package of other components, not just the API, but you have other things that are running on your laptop to fulfill what this is, not just Node.
The only other thing that I have installed on that I needed to have installed on my machine was the AWS SAM CLI. That's it.
But it
I
gave you a
take that
package
back.
of things,
And Docker, because
And it-
under the covers it's running Docker.
but it gave you a package of things, which you said is like the API gateway.
Yep.
Is there anything else other than the API gateway or any storage component that's already there, part of the CLI, or?
You getting it like S3, like an emulation of S3, or
Well, I'm wondering what's in the total package of the SAM CLI, because it sounds like there's more than just Docker, that you just need Docker and a package.
Yeah, how much of AWS is emulated?
in the case of the AWS SAM CLI, very little. It really is API gateway and Lambda is what
Okay.
it's truly running. Now, what it also allows me to do, which I'll show you in a sec, is I can invoke Lambdas separately as well. Now, what I do run locally as well, and it's at the end of the presentation, I have a couple of commands that you can put into either your bash RC or, in my case, ZSH RC, that would allow you to launch DynamoDB locally, right? Or to load Elasticsearch locally, that's essentially our environment.
Okay.
There is an AWS clone to run locally, which has almost an enormous number of the services of AWS that are emulated on a local machine. Like, I really truly want to run as if I'm
Like I can see that you
SQS
wanna have,
locally.
like,
What's that?
CloudTrail,
Yeah,
because you want to be able to like do your basic logging.
Sure.
For your development environment, and can you chain Lambdas? I know that one of the things you do for like authentication is have the authentication hook.
yeah.
for
So
your
there's an
Lambdas.
authorizer, right? So in API Gateway, you can set up an authorizer to run Lambda. We haven't connected it in yet on the local yet.
Okay.
That's something we'll end up doing, I'm sure. They've been out with this a couple weeks, yeah.
Does the SAM CLI support all the Lambda languages or just Node?
It supports everything, but there was one that they're not up to date. Python for sure,
Go.
Java for sure, C#. There was one that they just weren't up to the latest version, and I.
Go maybe.
That's the one. Is that the? Yeah, if you look on the AWS SAM CLI.
Well, I knew of a clone where it was like a bunch of Python scripts that would do all the services.
Yep. The Python. So it's interesting. So here's what they changed just recently in the last 9 days with this release. The whole thing used to be built in Go. They completely replaced it. It is now 100% written in Python. And they open sourced both the SAM project, which includes all the build scripts of CloudFormation, and this one, being the CLI, in Python so that they could interact, and they'll start taking public contributions. So it really is intended to be an open source project. So it is all built in Python. I don't know if you guys can see this, so here's the language runs. Supported runtimes, .NET Core 1.0, but it will run 2.0. I don't use either, so I couldn't tell you. But Node all the way through 8, Java 8, Python 2.7, Python 3.6, etc. Okay?
There is no Go.
Yeah, no Go. Okay? There you go. All right.
Rust on.
Let me continue on. So that was in terms of being able to run and to do, you saw how I did in init, and I started a new project, and it did an initial build. They've also added the ability for, let's say as a company, we decided we wanted to have sort of a stock way we do our serverless projects. Wouldn't it be great if I could do SAM init and then point to a GitHub repository that was our starting point for the application. They've just added that recently as well, which is pretty nice. Getting back to our application and what we were talking about before, if I wanted to run the API gateway, which I already showed you now, so this is, what if I wanted to go from api.scores.io to being on localhost 3000, and that's what I just showed you, right? And that's the SAM local start API that I showed you earlier. So then the next one would be the ability to take and do invocations of individual lambdas. And so the ability to take and point, if I wanted to, let's go into Columbia SAM local invoke. So if I wanted to call that hello world function, hopefully you guys can see it down there, hello world function, I just point to a file that holds what the event is, and that's just the variables, the parameters that are coming in. So for example, in this application, I'm going to put in this test directory, I'll just create a little folder called events, and all I'm going to do is add a new simple.json event, and all it's going to be is open and close brackets. It literally has nothing. Well now, so now I'm going to take and run this SAM local invoke hello world function, which is the name of the function in the template YAML, and then I'm going to specify an event file to pass into it. And so now it's going to take in, just like the API gateway, but this time on its own, it's going to take and invoke that Lambda, and it's going to give me back a response. Now, I probably wouldn't do that for something that I'm calling through the API gateway. But if I wanted to simulate the DynamoDB stream that's now supposed to send an email out to someone, I might use this. And I could actually use it for testing, right? Because I can do an invocation and see what comes back, and then I can use that for my tests. Now, for more advanced sort of events, I can also take and generate. So you remember I said those events can get kind of hairy, like all the data that gets passed in from the API gateway or from S3 or otherwise. I can take and actually, it'll generate sample ones. And I'll give you one example of that, and then we'll keep going. So if instead I do SAM local, local generate. So this time I'm going to generate an event, SAM local generate event, and I'm telling it it's of type API, so what would come in from an API gateway, and then I just specify where I want it to put the file. So I'm just going to pipe that out to a file. And so now, if I go back to this events directory, I can see an API JSON. This is all the stuff that would come in from an API gateway call. And I can mess with it. I can look at different features and factors to it all along. I could do the same thing if I wanted to, instead of API, and I wanted to do an S3. I did not test this one, so if it breaks, I apologize. There we go. So here's what comes in on an S3 event that triggers a Lambda. So at any rate, if that doesn't make any sense to you, that's okay. That's just an example of I can generate events for the purpose of testing. I guess it's okay to me. Okay.
Two questions. Could you go back to the picture with localhost 8000 for your DynamoDB? Yes. So on that picture, how does one create that local DynamoDB, and in the case where your Lambda actually generates a notification,
Yep.
how would that manifest itself? Would that manifest itself as standard output?
How would which? The notification itself
Yeah.
that's going to go to SMS?
Yes. How would you see what that notification looked like?
Essentially what you can do is you would do that invocation. You know how I did on the command line here?
Right.
Right, when I ran this one that's up here, that is the
Basically asking,
response
how do you
from the
get-
Lambda. Is that what you're asking? Is
Yeah.
sort of-
So it would just spit it to standard output, right?
Yep.
Okay. How would you create that local DynamoDB? Sorry, and if that's.
No, it's a
little-
great question.
If it's too much for this, then that's cool.
I'm gonna cheat ahead and then go back just because I don't wanna leave you on pins, maybe it would have kept you here. When I post these slides, you literally just you can copy and paste this into your Z shell or bash RC file, right? And basically what I do is this creates an alias
Right.
that's a Docker version of DynamoDB,
Okay.
okay? And this is an alias that'll stop it, and all it does
Sure.
is Docker stop. And all I do is DynamoDB start, and then if I don't use open, I go to the browser and hit 127.0.0.1.8000 with /shell, and I can just play with my DynamoDB.
But then how do you tell the SAM that it's there in port 8000?
That basically, when you do your DynamoDB configuration, you can specify an endpoint. So with local development, and you don't get that on AWS itself, you can only do, I shouldn't say only, but you only typically would do that in a local environment. You can
Right.
actually specify an alternative endpoint for
Okay.
that config.
Okay, so you just pipe it together.
Yep.
Okay.
It's really pretty straightforward to do, and we've been doing that for the better part of a year. It's been actually really, really helpful.
So to net it out, you create your dummy database, you can create dummy events, which you can then manipulate to create the input into the Lambda, and then the output of the Lambda always comes as standard output.
Makes sense to me.
Is that right? That was a
Yeah, I
question.
mean, we don't tend to deal with it in standard output. Like, we don't do those invocations a lot, right? If I was to write tests, matter of fact, I'll show you what their test looks like. And this isn't exactly the way I would rate the test, but it gives you a good idea, right? So in this case, they're requiring that Lambda file. They're calling chai and the expectations out of chai. And then in here, basically, it's calling and doing an await on that Lambda handler. This is the event context, and then the callback is the standard Lambda signature, right? And so what it's going to do is it's going to call that, and then the callback will run, and then it's running expectations. So what it gets back is a response object from the Lambda itself, and then we run the automated tests in here. Now, we don't tend to use callbacks, we tend to use promises, that kind of thing. But this is their generic flow, which is actually pretty good. And I think it's pretty clean and straightforward. So that's what we would tend to do. And then for those external services, for example, SNS, probably not going to run SNS locally. Nor would I necessarily want to, because I don't want to send emails out or text messages or otherwise. I would mock it, right? So I would mock the response that comes out of SNS. That would come back through the Lambda and return back as an object response, and then I can do that test. I could also spy on the particular calls to the SNS service. There's also there's an AWS SDK mock that allows you to, it basically provides mocks for all of the AWS services. We use that pretty heavily. Okay? All right, let me continue on. So the next suggestion that I would make to you that we found as we went through this was to consolidate your repos. When we started this process, we were like, this is awesome. We're going to have all these microservices, and this is everybody talking, microservices everywhere, and it's going to be awesome. And this isn't this is very much about AWS, but it's about microservices in general, which is microservices in general can lead to lots of cross-dependency issues in time sequencing of, for example, when I have, let's say I have a microservice that's going to be my user's microservice, and I have another microservice that's my scores microservice, right? And we're not talking about the lines of microservices and how you should define them, but let's just say I had this, right? And let's say that scores needs to know what authorization it has to do for some of the services it has. If I put these all in separate sort of in separate areas, I have cross dependencies of deployments that become problematic, right? And there's no doubt that separating projects is a good thing, right? And helpful, that's a really great thing.
It's a really good argument why it's not.
Yeah. Oh, in this case, but here's why, okay? Monorepos turn out to be a really good solution. What does that mean? It's not a monolithic app, right? That would be the alternative to this. It's not a monolithic app. It is the separation of concerns and the separation of deployment capabilities within a single repository. So instead of me using a separate GitHub repo for these, what I could do instead is I'm going to have one repo. It's going to contain 2 separate projects. And then I can use things like Yarn Link or other ways that you can with package management to do development on a temporary basis. And then what I can do is I can commit it together. It's going to get deployed separately, but it'll get deployed at the same time through my CI/CD system. Meaning this all goes into a single code repository. My CI/CD system checks it out, and it's going to deploy this one way and that one another way, but it's going to do it all at the same time. So it sequences those cross dependencies so they get delivered at the right time, in the right way, if that makes sense. And so that gets to my why. Handling cross dependencies in distributed systems is hard. And having them in the same repo doesn't solve that problem, but it certainly helps. It's often hard, in my little scores app, yeah, it should all be together. In a full-blown enterprise app or full-blown software package, it gets a little bit more complicated than that. And some of the other things that it does, ultimately, and I won't read all of these off to you, but ultimately it helps share code, right? Because what we found when we very first did this was, we did these separate microservices for a lot of different sort of element objects in there. Well, what we found was, for example, we created our own DynamoDB shared library, right? That was a client, DynamoDB client, that made it easier to interact with DynamoDB, okay? Or our authorization libraries. We did as, well, what did we do? We created a third repository called shared that these each included. And now not only do I have dependencies between these two, I've got dependencies to other things. It was awful. And it's just bad structure, right? But the question was, well, how can I deploy these separately and work on them separately, but at the same time have sort of a shared code base in a way? And so that's what monorepositories do. And the question becomes, who uses monorepos, right? And we try to justify ourselves on others. Twitter, Google, and Facebook use them. Etsy does the same. They all make use of monorepo. Now, I don't work for any of them, and I don't work for any of those companies. And the company I do work for is great, but it's not nearly that size, right? So is that really justification? Well, it turns out there's a lot of projects that leverage monorepos also, right? Just about any front-end project that you would use uses a monorepo. If you look, they'll have a directory typically called packages, and they have sub-projects with their own full-on development cycles that go on underneath, because that way they can coordinate it. So if you use React, there's a packages folder underneath that contains all of the different sub-packages that you would want to make use of. And they can be developed on their own sort of line, but they all work together. Angular the same way, Ember, Laravel, Symfony, there's lots. Yeah?
Sounds kind of like a JavaScript problem to me, because like with Java, we have Artifactory and we put our shared dependencies in there, and it's kind of like Maven Central, I guess. So
Yep.
is that kind of specifically in your mind a JavaScript issue, or?
JavaScript's been an interesting animal, right? JavaScript is I've come to love it. I never thought in my life I would say that. Anybody who 10 years ago put JavaScript on their resume, you'd be like, really? It's an interesting environment. It is amazingly powerful, and I've come to love it. The community itself, there are times where it feels like the Wild West. There's a lot of competing interests and practices and all this other stuff. It's settling out, and it's actually becoming quite good. Artifactory is one example. What we've come to do is we set up our own private registry, similar to what you would do with Artifactory, that is actually serverless based. There's a project called CodeBox, CodeBox NPM or something, CodeBox something, it's CodeBox dash something, that is a serverless private NPM registry. That works quite well, and it works like Artifactory, so we can do all the versioning stuff. The thing that my developers cared a lot about was, what if I'm not ready to publish that project? Like, I'm not ready to publish a new version of this. I'm trying to work with how this library works with what I'm doing, because we're building as we go. In that case, we need a way to not use the published version, and so that's a challenge. I don't know if that answers your question. Part of it is really JavaScript.
But you're gonna have that problem in any microservices-based architecture.
Yeah.
Because you have to agree on what the JSONs look like across the arrows.
Yeah, I mean, yes, definitely so. What are the interactions? I mean, in this case, it's about leveraging inside your code packages. So it's not about calling back and forth, it's about sharing packages, right? And actually, these all happen to be JavaScript based. The fact is I had on the slide earlier, but it was just too much stuff. Laravel and Symfony are both PHP libraries. So the bottom line being, using a mono, so let me show you what a mono repo would look like quickly. So this is the application that we've been working on all along. And if I wanted this mono repo, I wanted to combine multiple Lambdas within this repo. What I could do is, I'm just going to actually take and create a duplicate of Hello World and call it Hello Columbia. Okay, so now I have two folders under here, Hello Columbia, Hello World. And within here, I'm just going to go in and change my package JSON. So this is Hello Columbia. I think I'm okay there. That I already had is Hello Columbia. And I'm going to change my test, which was checking for Hello World before, to be Hello Columbia. Okay? So essentially what I have is two separate distinct Lambdas that I could publish that are within the same repository. Within what I can do is I'm actually going to run my tests, and I already know they're going to fail. And there's a reason for that. So I'm going to come into here with this AWS Columbia. I'll go into the Hello Columbia and type yarn test. Oh, no, I didn't copy it direct. It was, I'm sorry, someone saw something?
It was looking for options. Now find module options.
Tell you what, let's go back and go to Hello World for a second. This one's going to fail because I changed the text on it. So here, this is the test for Hello Columbia to Hello World, and that's because you remember earlier I changed the text on it. Fix that. And I'm going to show you something that's kind of neat to this. So my test passes on Hello World. I'm going to go back to Hello Columbia and see. It's because I did an exact duplicate. Okay. So I now have two Lambdas that are sitting in here, and they're sitting separate. Well, imagine I had 30 of them. I have all these different Lambdas that do different things in the system. Well, what I can do in this mono repo is, well, what if I took and put a single package JSON that was for the overall project? And then I could take and run yarn test, and it would run the tests of everything underneath, right? That's an example of a mono repo approach to it. So what I'm going to do is I'm actually going to cheat and go grab it from a separate project. And so in the case of this package JSON, I'm going to call it, this is for this application called AWS Columbia. Pay no attention to these yet. And so what I have is a single package JSON in this folder, in the root folder, that allows me to take and run the tests of everything underneath. So what I'm going to do is I'm going to run yarn install. I'm going to run yarn test. And what it did now is that based on that, on this line here, I can recursively call all of the tests within the system, get a single report, and now I can push and deploy, if that makes some sense, right? So the idea being is that now I've centralized something. Now I'm going to go back to, somebody mentioned earlier about, well, what if you actually wanted to take and deploy this on AWS? You're running it locally right now. It's on this, you're in this little local world. Well, now what I can do is I can take and include in here a package script, pre-deploy and deploy, these three, that are going to allow me to take and deploy all of my stuff, my entire structure. And there's one thing that I didn't do yet, which is, remember in our template, this is our template YAML, the CloudFormation. Well, I didn't add another function. So I'm going to call this Hello Columbia function. And it's in the directory Hello Columbia. It calls the same handler, it's the same version, and I just need a different path. And I'll make that Columbia. Okay? So just now what I did was I added a new Lambda called Hello Columbia. I added it to my template YAML file. And now by storing that, what I can do is, first I'll do it local, then I'm going to show you I'm going to launch it. So I'm just going to restart that API, and it'll even tell you, it'll say, okay, you've now got Columbia and Hello running, and I can go back out to my browser. So Hello is still running. Let's show that. And Columbia is running too. It says the same thing, but it's the separate URL on it. Does that sort of make sense? What I did there? Okay. So then for the final piece to this, what I want to do is to actually deploy this thing. So as I mentioned, I added package, pre-deploy, and deploy. These are steps, if you're familiar with AWS Serverless. It's what SAM package does is it takes and grabs all of the assets of this thing, puts them up on the S3 bucket so that you can deploy it to Lambda, and then deploy says, okay, take that thing that's up on the bucket and now launch Lambdas with it, right? So what I'm going to do is within this script, I'm just going to say yarn deploy. No, it's actually not going to work because I didn't give it any credentials. I got to tell it what profile on AWS I'm using. There we go. So first thing it's going to do is it's packaging it. Then it's going to upload it to S3. So it's successfully packaged it. Then it does SAM deploy, waiting for the change set to be created, waiting for the stack to be created. Waiting for the stack to be created. Let's give it a sec. Usually runs a bit quicker. That's not on you, that's on AWS. See how easy it is? All right, we'll come back to it. Actually, I think if I remember right, Robert, when you did this last year, that it slowed down like right as you were going through for a minute or two. Yeah. I don't think they like Columbia. All right, we're going to come back to that in 1 second. and show the actual deployment. Just moving on, the next piece to this that is really hard to get your arms around serverless-wise is how do I debug, right? I have a system that is all of this stuff. I've got Lambdas, and I've got DynamoDB, and I've got API Gateway. What is the best way for me to be able to take and see what actually is going on? What is slow? What is fast? What do I have to refactor? All of those pieces. X-Ray is their answer to doing that. And what X-Ray does is it allows you as a consumer to log into a web console, so you as an administrator to log into a web console, and you can see a graph of everything that's run in your distributed system, okay? So I can see, and this is an example they give, that this Lambda calls this Lambda that calls S3, and I can see here that this is 0.6 times per minute, and it averages 0.32 seconds. This is 0.00 seconds, that is 0.05 seconds. So I might want to spend some time here seeing how to make it faster. And I could even say, well, let me click on this and drill in and go a little bit faster and dig into how long each component piece of the overall system runs, right? The way to do this is actually quite straightforward. I'll show it to you in the actual template. It literally, to get started with it, and this isn't everything, but to at least just get it going, I literally have to do, you just say, tracing, active. X-ray is now turned on as soon as I deploy this. And I'll do the same thing down here. X-ray is now turned on for those Lambdas, and it will show in the X-ray tool within. Yeah, that changed stack. So this was the stack I did earlier. That did finish. So X-ray, and I'll actually take and deploy again, this time with X-ray in place.
How come it didn't give you your URLs?
I didn't have it output that directly, but what it does is you can go into your cloud stack. So this is the AWS console. You guys might remember at the beginning I talked about how everybody gets their own account, right? This is my account within here. If I go to CloudFormation, this SAM Hello World is the app that we just deployed. Ooh, didn't like it. At any rate, the outputs are here. So here is the actual URL. Because the API gateway it dynamically generates, because obviously lots of people push it up. And if I go there, I can go see the hello telling me kind of thing. But the other thing to take in and just show, let's see if this guy. The one thing I didn't do was get permissions for X-ray. I'm not going to dig into that too far for you guys. The only thing that you would have to do here is you would have a permissions policy that goes down below. I don't want to derail you too far. If you have questions afterwards, I can walk you through and set it. I want to get the final point that I just wanted to make presentation-wise is, so in the case of X-ray, you can also take and add it when you do your DynamoDB call. You simply wrap your require AWS SDK in a method on this AWS X-ray library, and all of a sudden they get all that mapping that goes with it in X-ray. I can show you, I'll come back to that and give you a brief example. The final suggestion I would make, if you are going to get into this, if you've ever used like your typical application server stack, you'll have this notion of middleware that does a lot of the sort of mundane chores for you that you know. So if you've used Express or you've used Rails, that kind of thing, it'll take and pull apart when the requests come in. So for things like CORS headers, right? When I did serverless and we first started, we're banging out CORS headers to be included in the response. I'm like, why am I doing this? I'm having to deal with all kinds of issues. So authorization, CORS headers. I have a JSON string being submitted. Wouldn't it be great that when I got to my Lambda that it just had a JavaScript object that I could mess with? Middleware can help you with that. The way middleware works is, so I recreate this Lambda. When the request comes in, basically any of the middlewares that I assign can take and do special chores for me. So there's a specific library called MIDI that if you ever do serverless, check out MIDI. It will do almost all of these things for you. It'll do your error handling and your JSON body parsing and your CORS headers and your caching. All of those things are just taken care of, which is really quite nice. And the actual code to put them in is very straightforward. It's simply you wrap your method in your handler in a MIDI function and then tell it which ones to use, and it just applies it. And again, I've got URLs to MIDI as well, but that was the other sort of lesson learned that we had coming out. Okay. My final tips and tricks, the local DynamoDB reference, and then there's one other for Elasticsearch. I would tell you that we don't do any searching in DynamoDB at all. Anytime you're going to search, DynamoDB is terrible for searching. You would use an Elasticsearch index. And this is just a little snippet that I'll include when we put up the slides that'll allow you to run Elasticsearch locally as well. In summary, serverless allows you to focus on code, not servers. There's a couple of special things I suggested. Leveraging the Amazon CLI, consolidate into a monorepo, debug using X-Ray, make use of MIDI for the middleware as you go. I think that's it. Any questions? Yeah?
Okay, so how much did you save going from like EC2 instances to going serverless?
We built this app from scratch using serverless for the particular app I'm working on now. The key piece to it, but I've seen, matter of fact, I think, Robert, you included in your presentation, I should bring up his, a presentation where they reduced their cost by like 70%. The bottom line being, so, and I have some slides, and I'm not going to make you go through a ton more slides. The bottom line is that those Lambdas cost you zero until you've run them 1 million times a month. Okay, so there's zero cost for Lambda at all until you get over 1 million. For API Gateway, same thing, 1 million requests per month for free, and then you start charging on there. DynamoDB is the only thing that you pay up front because it's based on provision, like you have to say how much throughput you need, but it can auto scale up and down, so you can start at super low. And so, for example, our development app, we run, I don't know, we were running in the $800 to $1,000 a month, right? Almost all of that cost is Elasticsearch. Our cost for Lambdas is almost nothing, and DynamoDB is the only one that costs anything, and I would guess that out of that 1,000, if it was $60 to $100 a month, that would be where I would guess it is, and that's only because it's running massive loads on a regular basis right now, so it's provisioning it up, and then it drops it right back down. So if you wanted to start working on a serverless app, you could literally do it for nothing right away. DynamoDB, you can get the free tier, which is, I should pull this up.
It's like 5 operations.
It's like 5 now.
Yeah.
Which is more than enough for a build.
Actually, there we go. That's not the slide. That's good. There we go. Yeah, so API Gateway, 1 million requests of free per month, every month. Then it's $3.50 for the next 1 million. 1 million requests, then it's 20 cents for the next 1 million. And there's some add-on to that, but it ends up being extremely light. I was shocked at how cheap it is, and remembering that it's multiple data center, and it's doing all those crossovers. For the first probably 3 to 4 months, our actual AWS costs exclusive of Elasticsearch was 0 for Lambda and maybe DynamoDB we paid for a little bit.
Those are the two, DynamoDB and Elasticsearch.
Yeah.
That's almost the majority of our bill.
Yep.
But isn't S3 also included in here? I mean, you deploy to an S3 instance.
It's so light.
S3 is free.
I mean, S3 is, and I didn't put the cost up here.
It was, last month, it was $1.63.
Oh, wow.
And we are, mind you, we've got, you know, a team of 5 to 7 people that are deploying all day, continually putting that, like, it's nothing. And the fact is the CloudFormation packages that we push are, I looked at it today, it was like 2K. Because the Lambdas are so small, right? Because they're only individual component units, and they don't contain all of the sub-libraries. They actually get exploded into node modules as they go, once they get deployed. Yeah.
Is there a cost on X-ray? You get X amount for
There is, but I don't think we've ever
Yeah.
paid for it.
We have,
Okay.
we paid, last month we paid $2.
There you go.
Okay, wow. All right.
Yeah.
So it's bearable.
Yeah,
And the
to be honest,
back
what we
end,
pay most for is support. We pay $100 a month off the top just for
Oh.
support.
Yeah.
And that's literally a fifth of our bill.
And to be clear about that, so the support, to defend my support bill. So what does support get you? When you sign up with AWS, you can do email, basically you fill out a form and they get back to you, and they're actually pretty quick about it, they're good. For the $100 a month, you can get instant chat or instant phone call anytime on that stuff, and they escalate you pretty quick. So for us, as we were going, we wanted the right answer, and so it was pretty important that we needed it as we went. Yeah, a question in the back.
Is there any step function support in SAM yet? Or
That's a good question that I don't know the answer to. And it's funny because we were looking at that because early on, SAM, the step functions, like the only way you could use them at all was in the console, like the web-based console. I was like, this is a complete waste of my time because we try never to deploy anything in the console if we can avoid it. I don't know. I wish I knew. Does anybody else have an idea? No. I'll look it up.
I didn't know because you, with SAM, do you know if you can support aliases and versions as far as being able to roll back your deployments and stuff? Or is that getting?
It's a great question. And it's actually something we literally talked about this morning. We haven't used it that way. My recollection was that you couldn't because SAM takes care of like when it sets your next, and this is a year ago, when it does the deployment, it assigns a unique identifier to the end. So like if you look at the list of functions that get deployed, let's go. So if you look, each one of these has like a special identifier to them. So these are the ones here. That's the hello Columbia function that I did. Right? It's down here. Like here, you can see it gives an identifier. I actually have on my list of notes to go back and return to that because it would be great if I could alias and version that way. What we find is that we do all of our versioning through GitHub versioning anyway. And so rolling back wise, in our CI/CD system, for example, we had a deployment that went bad on staging. We just went into the CI/CD system, went 3 back, and hit deploy on that one, and it came up just fine.
Okay, see what we were kind of looking at, or what we did do originally was we would have aliases that would point to version 1, 2, 3, and if 7 went bad, we just pointed back to 6, so it was like instantaneous.
Yeah, it sounds awesome. My recollection was that when we looked at the SAM stuff, somehow precluded that, but I could be completely wrong.
Probably want to do that with your CI pipeline anyway, not with SAM itself. So
Right.
you basically tag your version
Yeah,
and just put that version.
yep, definitely so. Yep, I think you had a question?
I do, it's very esoteric, so if you don't want to answer it or later, that's fine.
No.
It's about Lambdas hitting APIs, but you want that to be encrypted. with your private cert, okay?
Yeah,
So typically the way that's done is you have a trust store, and you say, this is my private cert,
yep,
or this is my list of private certs, and if you hit this API and it happens to have one of these 3 or 4 trusted certs, we're good.
yeah.
Right? We're having a, so again, this is very esoteric. So in .NET, it turns out that they don't support that,
Okay.
just FYI. It seems, have you done that before? And if you've done it, what languages have you done it, and how did you do it?
The simple answer for me personally is I have not done it.
Okay.
I know that we would,
Lambda calling another, you're talking about?
Just some random endpoint somewhere.
External endpoint?
No,
So
well,
you-
for this discussion, let's assume it's internal.
So you'd use IAM for that?
No. You want to hit an endpoint, and you want it to be encrypted, and you want to know that you have a trusted cert. That thing could be an on-prem system, it could be your laptop at your desk, it could be, my iPhone. Anyone could be servicing that API.
You'd be a
But-
subscriber.
Right, so the thing is, you normally would draw a boundary around what's inside AWS and what's outside.
Right.
And internally, you control everything to the IAM, and externally is something else.
yeah, it was interesting
I
actually.
agree, but
Yeah.
again, this is from the perspective of what happens if there was some bad actor
Yep,
that got inside our VPC
yep.
and stuck a server in it. How would I detect that? I mean, that's what this is about. That's why I said it's
So what
very
you're talking
esoteric.
about is
This isn't
essentially, it's a client cert that you're trying to use in order to access it. We didn't have a need for client certs.
Yeah.
I'm trying to think of,
The only way that this is outside of
Yeah,
AWS
yes.
and how you can solve this. In Java land, there is something called a key store. It
Right,
is
the
a
trust store, you
key
put it in the
database.
trust, yeah.
Therefore, you can
But-
stick your collection in there.
That's
All
right.
you have to do is say, am I in the collection of the key store, and therefore you say, use this cert.
So
You
in
have to
something
do
something
this.
like Java, what you can do is you put your trust store in an S3 object, and
Yeah.
then you could at runtime, pull that S3 object and look for that. My question is specifically around, is that kind of the standard operating procedure that people have done? And,
So if you're
and I can tell you that won't work well. Again, this is very esoteric stuff. I was just wondering if this is something you do.
yeah. So the one,
API gateway itself can do that?
No, we can't use, API gateway is open to the entire world.
in terms of the inbound,
Yeah.
in terms of the, you could use, I mean, I guess the custom authorizer you could use.
No.
No. Okay. So from the perspective of the storage of the certs themselves, whether you put an
Yeah,
S3
I'm
otherwise.
just asking, I've got a Lambda function, I've got this blob of code that's running in a Lambda.
Right.
I want to make sure that I'm talking to someone with a known cert.
But you're saying API gateway, you couldn't verify that cert anyway on inbound?
No, because that API may not be behind API gateway.
Okay.
It could be running on my laptop at my desk, right?
So you're talking about, so the event trigger itself has to have a client cert calling, that would be, I think you're back to IAM though. The only way that you're gonna get at that, I guess you would do the SDK.
No, it's like you said, like in Java, the way you do it is with a trust store, right?
Well,
The-
a trust store can handle multiple certs. In other words,
Right.
it's a cert database.
Right.
Okay, and this is not just Java, you can do this on any web server you want to and just use a key store. And therefore you use an SSL directive to say, use this store, and if my key is found in there, you're fine. That's
So-
what the trick is. But your key, the same key, let's say that you have multiple key stores.
Yep.
I gave you the key store and I got a key store. Same keys have to be in each one of them for that to work. So it's
Sure.
point to point
Sure.
only,
So where this falls
with
down.
no authentication.
So where this falls down is in the Lambda runtime. Lambda runtime only supports certain things. It's not a full-blown runtime, right?
Also, it's just
I
like
think,
out.
actually, the more I think about your question, the more, less sense it makes to me.
It's okay. It's
Because
very esoteric.
it's
I
not
mean, I could draw it
UPS
out.
between Lambda to Lambda.
No. Lambda's just hitting an API. Someone's triggering a Lambda, right? Someone
Okay.
created an S3 object or hit an API gateway. The API gateway triggered a Lambda function.
Right.
As part of the workflow of that Lambda function, it has to go hit an API. To get something,
Okay.
right? That's what I'm talking
So you want a client cert inside your Lambda.
about. That's right.
Okay.
Well, around your Lambda. You need something around your Lambda service, so that you're basically firewalling your Lambda service.
But I guess where I'm getting a little bit lost is you're saying they first hit the API gateway. No, they're not. They're gonna directly call the Lambda.
Right, like through an S3 put.
Okay, so they do an S3 put, and what you want to do is they do that S3 put, and somehow it's going to be inclusive of that
And
cert.
part of the workflow,
Yep.
that's gonna trigger a Lambda.
Right,
Lambda's running.
yep,
Is in line 27 of that Lambda,
yep,
it's gonna hit some URL somewhere.
okay.
So you mean like do an HTTPS connection?
So routing
Okay.
Okay, so no
API
problem.
gateway.
Yes, problem.
No, you have a cert. So obtain your cert.
But I wanna make sure it's a trusted server. It's a trusted private server.
You
Gotcha.
compile it in.
Yeah,
No,
you have
but
to
you
put it
can't do
inside
that
your
without
package
that.
of your Lambda.
Yeah,
You would have to put that
That's
in
what I'm
your
saying.
Lambda.
The runtime's restricted. You can, it's not a full-blown, so I agree with you. If you're a Java programmer, I agree with you. You put in the right packages, you'd say, this is my trust store, it's some S3 object.
But
roll
you
on
can
it.
package in Lambda as well, is what he even demonstrated here.
Yeah.
That if you wanted to put your key store into your Lambda package, your key store would also be available, and therefore it would be included in the path, and therefore control your by SSL directive. I have no idea where you put it in Lambda, but that's where you would then take control of your validating your SSL.
all right, so the only suggestion I make to you in terms from a search storage point of view is in terms of secrets to be stored, SSM is the sort of the newer way to do it within Lambda. And actually remember I showed MIDI before? Essentially with MIDI, you can take and specify and say, well, give me these SSM parameters that are stored in a secure store. And it'll actually load them as environment variables within, and I don't know that that'll work for certs necessarily, but I'm just saying if you're trying to store secrets and you don't want to do them as sort of ordinary Lambda environment variables, or there's some place where you need to store secure information, that would be one way to go about it.
You could use
Yeah.
KMS as well.
Yeah, I was thinking of, yeah,
Whatever.
because KMS will do the key management store in general, right?
No. KMS is encryption.
Yeah, but you want to fetch the key.
And then you can use ACL as well.
Key that you're trying to connect to your remote service with.
No, it's a cert, it's not a key.
It is, it's a,
No,
the
it's
cert is a public-private key.
Okay.
That's right.
So why don't we take let's go back, it's a great question, I'm actually fascinated.
I'm sorry,
that's
like, that's
No,
what I'm trying
it's
to
totally
get.
good, and you prefaced it exactly
It's
right.
very esoteric.
Yeah. Any other questions on serverless or anything else that's come up? Oh, wow, that came quick, yeah.
So Lambda came out with blue-green deployments recently. Does SAM support that?
I don't know. We haven't looked, I know that, yeah, I'm definitely familiar with it, and I think it goes along with the aliasing, right? Like, you'd have to be able to do some sort of versioning and aliasing in order to take advantage of that, but I don't know if SAM does it. They just changed all this, so much of it, and yeah, I don't know. Other questions? Yep?
Have you played with workflows?
No. I'm familiar with like Amazon workflows.
Yes.
Yeah.
Where it's,
Like a process-based.
Yes.
It's almost like step functions to a
So
degree,
that's kind of
except it's.
deprecated in a way, you're really supposed to do step functions for workflow now. I
Yeah,
think.
I thought they transitioned that, yeah. Anyway, so,
it was expensive anyway.
was it?
Yeah.
Gotcha, yep.
Can Lambda DVR the cap scan for you?
No, but I've got PlayStation View on my iPad.
Well,
so
they
I'm-
can, but just 5 minutes of it.
Yeah, that's exactly right, yeah.
Okay.
Other questions?
When you run the SAM command line, it displayed that the function took around this much memory and also this many seconds.
Mhm.
Does it simulate what it runs on AWS, or is it dependent on the local operating systems?
Yeah, so the amount of seconds is a good question. I don't know how they come up with that specific. So it's going to tell you how it runs locally on Docker, right? And in theory, if you're running, not every Lambda container is identical.
Yeah.
So in theory, they could run shorter or longer. What you can control is the amount of RAM you apply to it, right? So what's nice is you can look in the local and say, you dedicated 500 megabyte to it. It only took 30, right? So you might consider backing that down. One suggestion, if you guys aren't familiar, like the single best way to sort of monkey with the system a little bit in the case of Lambdas is the one thing you can control in that template file is the RAM, is the memory allocation. And you say, well, what do I care? Like, it's going to take as much as it takes. The reality is that's how Amazon specifies the processor you get. So if you use the 128 meg, so this is in that template YAML file, which is this here. I'm actually not specifying it in this one.
getting more IOPS with a bigger instance.
Yeah, and I can't remember if the key is, I don't know, I think it's memory. So like you would do like memory 512, right? By default, I believe it's 128. So you figure 128 is the default, and it's also where most people plan to use the free version. The processor you get is not great. We start at 192 with everything we do, even though it's slightly more expensive, right? So gigabyte per second, you're paying more. But what we found was, and we actually ran benchmarks, what we found was the 192 ran twice as fast as anything at 128 ran. So it was, and I don't remember the exact numbers, let's say it was 20% more expensive per second, but it ran in half the time. I saved money. Yeah.
So this is more relevant. So with, a long time ago when I played with Java, the Java spin up was about 30 seconds, like
Yep.
15 to, maybe 30 seconds is probably too much, maybe 15 seconds, give or take. Is that still the case?
No, for, you're talking about warm up basically is
Yeah,
what they're
yeah.
talking about, so warming. No, if, it
So
depends
it's
on
not
the
better.
Lambda, the actual startup, and Java's a little bit of a different animal
Yeah.
on Lambda, so it has more startup time to begin with from what I understand. I haven't done them specifically myself. In the case of Node, I would tell
Node is
you,
always very fast.
yeah, we run, I mean,
Startup is fast.
yeah, it's less than 100 milliseconds. And once it gets going, it's,
Yeah, they keep them.
yeah, it's crazy. Yeah,
Kind of answering his question, I'm one of the Java guys, you probably guessed, but there's about a 40-minute time frame right now that it runs, and so you can have
You can ping it.
basically a warm-up operation where you can hit it every so often to
Right.
keep it warm,
Gotcha.
that kind of stuff. It's kind of interesting too, another counterintuitive performance thing for like the Java Lambdas, like if you are, heaven forbid, connected to a JVC connection, then you don't close them when you're done, and
Yeah.
you leave them open and they stay there and you keep it warm in your JDB6, which is the exact opposite of everything that you were taught. But
Yeah,
gotcha.
because you're trying to just have it run and only get charged for your individual runtime.
yeah,
So it's like an anti-pattern to it.
yeah.
Yeah.
Well, if you look at it that way, like we have a reason to go to JDBC connections, but
No,
so you can almost look at your Lambda pool as like a connection pool.
Well, that's one way of doing it.
But
I think it's you're not charged for the time when it's warmed up, but
yeah,
not yet
exactly.
recycled.
Oh, really?
Exactly.
Yeah.
Yeah, you're not.
Oh, wow. No, that sounds like a good idea then.
Yeah, that's exactly what we do.
And
But-
actually, one of the MIDI middlewares, which isn't listed here, is warm up. They actually have a middleware specifically for helping you to stay, to
Really?
keep your Lambdas warm, yeah.
Yeah.
It's an amazing project, it's actually very cool. We used almost none of them straight out of the box, like they give you the MIDI sort of framework, and they have a dozen middlewares that they're available. We almost always tweaked them, so we have our own version.
Yeah.
But it's nice because they're open source and we can just make it a little better. Yeah.
What kind of approaches have you had for error handling? Like that situation where like our Lambda relies on a less than reliable external system that may have like 4 hours a week of downtime.
Sure.
So there's depending on how the Lambda is invoked, there's different ways that it'll get retried and stuff
Right.
like that, but sometimes they just fail and you're done. So
Yep.
what kind of approaches have you dealt for queuing those up and retrying them at a later time?
Sure, I mean, obviously, so what they would recommend, I think, is the dead letter queues that come out of it, right? Like that you can watch, that they support dead letter queues that you can say, okay, after this amount of time, when it finally drops out, you can take a look at it. With our data so far, we haven't had to deal with it because a lot of the data polls that we're doing are from internal systems, so we never run more than 24 hours behind on what those requests are going at. Yeah, I guess the best way I would say to do it is, yeah, I don't know that I have a good solution for you there.
See, I guess the challenge for us, we're in the process of going from on-prem to cloud, and so we have systems in both ends, and that's the kind of, whereas maybe you are everything in the cloud, so you have a little more
Yeah.
resiliency,
I won't say we're everything in the cloud, but we're certainly trying to be.
mostly.
We're
Are
getting
you
there.
saying that your data for that 4 hours, that if you were to fire onto that service, that you'd have to recover that data for that 4 hours, and therefore you'd actually have to reuse that data?
Yeah.
Okay. The way that I've done this in the past is because I work for a healthcare provider, and no data was ever allowed to be lost. Zippo. we had an incredibly depth-long queue. Everything, as he said, went to a dead letter queue, but we called it the all-error queue. And if you turned on the all-error queue, it was 1 million deep. And as soon as you hit halfway through it, an alarm went off in the system, and someone was being called.
Yeah.
You
We
were
have
not allowed to
almost
hit 500,000.
We have almost exactly that same solution, and I was hoping there was a better solution.
No, because you have to keep state. You just said that you have to keep state.
Yeah.
But, well,
Lambda doesn't have state, I mean, that's part of the thing, right?
Yeah.
Well, no, that's fine, but he can't lose his data is what he said.
And order is important.
but I almost wonder what, oh, interesting.
FIFO.
Yeah, it's a
Yeah.
fine.
You have to use
Yes.
queues. I mean,
Yeah.
I don't see a way.
Well, so if you were to put those requests into, and I don't even know if this is even feasible. If you were to use the, I mean, one of the things that we started doing, because we were using, this was a switch in our approach. Originally it was, for example, if we're going to update a broadcast and then the broadcast has to rematerialize the station, it has to trigger this rematerialization. We were doing all of it from Lambda, looking at it almost like a controller, right? Like, we're going to do this, and then we're going to do that, and then we're going to call this other service, and when that gets done, we're going to do this. We pulled all of that out and switched to nothing but DynamoDB streams, right? Because the DynamoDB streams for us was, okay, if that Lambda tries to do that event, like we saved a record, now we have to rematerialize. If that fails, it stays in the stream until it goes for 24 hours. Now what I would wonder is if you could make use of CloudWatch alarms, like some sort of logging like alarm, so a custom alarm that would take and trigger, because you can use CloudWatch alarms or CloudWatch logs to trigger Lambdas, to basically trigger it to sort of start again, or somehow refresh itself, but I don't know. Yeah.
Can we use a similar architecture for high I/O or CPU utilization application?
Higher CPU utilization?
Or I/O?
I'm sorry?
I/O applications, more input and output, more function calls.
I would say probably not, only because it depends on the amount of sort of storage that's in there. They limit in Lambda, it's like,
5 minutes.
yeah. Well, so you've got a 5-minute processing time is one thing, right?
That's
and
from request to response is what you're saying.
What's that?
That's from request to response.
Yeah.
Total time is 5 minutes.
Yeah, your total time is 5 minutes is the maximum that you can actually apply it, and there's a limited amount of disk space within the Lambda itself, so.
It's
Yeah.
not really built for heavy lifting.
Now, Dan, were you the one that, somebody did a presentation previously about,
Think of it like a thread.
what did they call it?
Just
The,
thread. Target.
no, it was about Lambdas, like basically creating fat Lambdas, I think it was called. Was that your? Yeah. So there's a fat Lambda presentation, I assume you have that online, that might be interesting, that's sort of like dealing with a way to do, what was it, EC2 instances?
No, it's all like ECS, so it's Docker containers. But
Yeah.
in Fargate, so you don't need to provision anything.
Yeah, so you might go that direction. The other thing is, it depends on, the amount of processing. Lambda's used quite a bit for like video processing, taking small segments of video and so like, transcoding a video of the individual, like using HLS, taking the individual sort of chunks of it, doing all the transcode and essentially, what's the word I'm looking for? Yeah, well, blasting it, basically to take and blast out multiple transcoded versions, but it's not high I/O.
Because we never got a chance to select the RAM or the database, right? The size. So that's what I.
On the database?
No, not the database. In the serverless architecture,
Yep.
we don't have the choice to configure the RAM or the amount of CPU like how we do at EC2, right?
CPU, no, but RAM, yes. So the RAM you can specify, and I forget the I don't know the upper limit. It's a good thing this isn't my AWS exam. Yeah, so at any rate, there is an upper limit to the RAM, but it's actually pretty beefy, and if you increase the RAM, there is, and they don't tell you specifically what the processor is that goes aside with it, but by increasing the RAM, you actually are increasing the processor that it gives to it also. So there is a way to sort of measure it and give it more beef to try to get something processed quicker. You have a little bit of control, not a ton though. Yeah. Other questions? Wow, 9 minutes from 8, this is great. Awesome. Thank you guys so much. I really appreciate the questions.